We are starting day 2 of domain of discrete functions. I need y'all to look at your unit 2 divider so that you can add a few things. So one of them is where we're talking about relation function and vertical line test. Go ahead and add this phrase. Y is a function of x out to the side. The way it's going to be tested is it's not just going to say, is this a function? It's going to say, is y a function of x? Okay, the next thing is domain and range. So domain is the x values. So go ahead and put an x out beside domain. And range is the y values. Yesterday we did Dachshund and ride. Dachshund is to help you remember that domain, the DO stands for domain, is the x values, which is your independent variable. Ride is to help you remember range as your y values, which is your dependent variable. Another thing that we need to change, because this was actually put in wrong, is on range. Range is a set of all possible outputs or y values of a function. It said inputs, so mark out input and put outputs. And then get out our foldable from yesterday, the one that says discrete domain, discrete range. We did domain, and domain is all the possible x values. So we did all this work yesterday. Domain is the x's. With discrete data is just list of points. So we can just list the x values. With range, it's our y values. So we're going to do the same thing, but with the y values. So open this up so you're just looking at discrete range. And let's complete the foldable together. So the range is the set of all possible y values. Other names for range are the output. You put in an x and out comes the y. So that's why it's called the output. It's also the independent variable. And it's also f of x, because f of x is the same thing as saying y. And we can also put y values. So if you have a highlighter, you can get that out, and we're going to use our highlighter or underline and make lists of the range. So number 1, from the ordered pairs, we are just writing the y values. So domain is x, range is the y. Because remember, we have x and y. Since we're asked for the range, we're just going to write a list of the y values. So 4, 5, 6, and 7. Number 2 says, what is the range of the function f of x equals 2x minus 3, given the domain is -2, 0, and 2. So it's asking for the range given domain. So remember, domain is your x's. So these are our x values. We want to find the y values. So it's similar to this one. The only difference is the function is different. This one says 2x plus 3. This one says 2x minus 3. but we're going to follow the same steps. We're going to go to our calculator, plug in the function, and then do second graph to look at the table. So if you don't have a calculator, you need to get one right now. So if you're on anything, to get back to the home screen, hit second quit. We need to put in the function. This is our function. F of x equals 2x plus 3, or minus 3. And we need to create a table of values on our paper. So write this on your paper, the table of values. They've given us the domain. So the domain is the x value. So I'm going to fill in the left side of the table with these numbers, -2, 0, and 2. Make sure you have the right function in the y equals. So to get to this, we push the y equals button right here. Put in 2x minus 3. And then go to the table of values, so second graph. And we need to find what the y values are that match to each x value. So look at our table. -2 matches with -7. Zero matches with -3. And 2 matches with 1. So we have the x's. Now we have the y's. We want the range, so we're just going to write out the numbers that match that domain. So the range is just the y values. From a table, go ahead and write your y values. What's the range? It's just your y values. So write your y values. And you do the little set brace, which is like a S and then an opposite S to this. We got to write them in order from least to greatest though. So stop. Write them in order from least to greatest. What's the smallest one? -4. What's the next one? -1, then 2, then 5. Number 4, what is the range? So this is our x, this is f of x. Remember, f of x is the same thing as saying y. So these are the y values, the range. So go ahead and write those. And they're already in order. Five and 6 is finding the y values from our graph. So this is our x-axis. This is our y-axis. So we're finding the y values. So we need to find the coordinates and then just make a list of the y's. So to find the coordinates, it's like starting at the origin and then following directions to get to each point. So left and right is first. So you walk before you climb. So I'm going to start, it doesn't matter where you start really. I'm going to start at this one. So start at your origin and count. How far left do we have to go? We have to go 3. So that'd be -3. And then 1, 2, 3, 4, 5, 6. Then the next one is negative 2, 3. Then this one, start your origin. We go left 1, and then we don't go anywhere else. So it's just negative 1, 0. And then to go down to this, we don't go left and right. So it's 0 down to negative 3. 0 down to negative 3 is for that one. And then this one, you would go right 1 and down 6. So 1, negative 6. And for range, it's just your y values. I'm going to highlight them. And then write them out to the side. We want to go from least to greatest. What's our smallest y value? So negative 6, negative 3, 0, 3, and 6. All right, I want you to do number 6 now on your own, and then we're going to glue it in. So go ahead and do number 6 right now. Okay, so check mine with yours. These are the coordinates I got. And we're asked for range, so we are just going to do our y values. So that should be a positive 6, shouldn't it? Oh, I've repeated for some reason. That should be 4, positive 6. Sorry about that. 4, positive 6. There we go. Okay, does it look right now? Okay. So let's write our coordinates. So from least to greatest would be negative 6, negative 2, 2, and 6. So you can go ahead and glue this in your journal now. And you are going to work on an assignment for the next 10 minutes. Okay, something you'll need to pay attention to is if the number doesn't have an arrow to it, you don't include it. So this, just mark it out. If they don't have arrows, mark them out because they're not part of the domain or range because they don't have arrows going to them. So same thing with that one. So that'll get you started. Remember to be a function. For every input, there's exactly one output. So it's either a yes or a no for that. So domain would be your x values. And your range would be your y values. And to determine if it's a function or not, just make sure the x's don't have more than one arrow coming from it. So every x only has one arrow pointing at a y. So this is a function. Okay, we are moving on to continuous domain now. I want to look at continuous on the vocabulary really quick. Continuous function is a function with any values between a certain interval, graphed as a single unbroken curve or line. So continuous means it continues on from one point to another, or it continues on to infinity. What we did yesterday and today was discrete, which was just points. They didn't connect. So continuous is where they do connect. The way we do domain and range is similar, but it's going to be on an interval because you cannot possibly list all the points on a line because there's an infinite number of points on a line. So let's look. Continuous domain. Domain, again, is the set of all possible x values of a function. Think of the x-axis. The x-axis goes from left to right. So we are going to see how the function or the graph extends from left to right. We are going to use inequalities. So we are going to represent a straight line like boundaries. We're going to close it in from left to right. This is a closed circle, which we're going to use a continuous line. We are going to use the less than or equal to or greater than or equal to. If we have a dotted line, that's whenever you have an open circle, and that's the less than or the greater than, not the or equal to. Okay, this will make sense once we actually do a problem. So just stick with me. So what the domain is going to be is it's going to restrict or find the boundaries like a fence. So think of it like a fence. You're going to find out where's the fence on the left and the right, and you're going to enclose the function. So these are the boundaries. Okay, so when we have two end values like this, look at this one. We are looking at the x-axis. We are going to find out how far left and how far right. So we are going to do the boundaries. So let's enclose the boundaries. So see how it goes from here to here? So we can draw a fence on the left and the right side like this. On the ends are closed circles. So we are going to do straight lines to make our fence. And if you have a highlighter, you can highlight the left and the right side. Like that. Or you can shade it with your pencil. It's fine too. So see how this has a fence on the going through the x-axis from the left and the right. I'm going to write the word L, or the letter L, and the R for left and right. So whenever we write our inequality, we are going to go from the left to the right. So how far left is this boundary? Start at your origin and count. -1, -2, -3, -4, -5. So I'm going to write a -5 here. And then how far to the right? 1, 2, 3. So that's our boundary. The x values are between -5 and 3. So we are actually going to write it. This is two end values. So it's going to look like this. You're going to do a number is less than or equal to x is less than or equal to the right. This is like your template. It can be or equal to if it's a closed circle, so don't forget that. So I'm going to put a little box here because it could be or equal to. So this is our number on the left, which is our smallest number. This is our number on the right, which is the bigger number. You go from left to right, and we use the less than symbol. Because what this is saying is x is between the left value and the right value. So we're going to use this template to do this. So you do the left value, so -5. Because it's a closed circle, we're going to do the less than or equal to x. So another closed circle is less than or equal to 3. So what this means is x is between -5 and 3. All the x values that you can imagine on this little curvy thing are between -5 and 3. And because we're talking about domain, it's x. If we were talking about range, it would be y. Okay, let's look at this next one. Draw your boundaries. Okay, so it's going to be right here, and it's going to be right here. But see how this is a open circle? So we're going to have to do a dotted line, okay? So do a dotted line with the open circle. And then a solid line with the closed circle. And then if you have a highlighter, or go ahead and shade the outside. You don't want to shade over the line that's been graphed here. You want to shade outside of it. And let's write what our boundaries are. This is the left. This is the right. So we need to write what number corresponds to this. So start your origin, go 1, -1, -2, -3, -4, -5. It's -5 again. And then what about this one? 3. So is it the same as this? Same but different. What's different? The symbol, yeah. The symbol on this one. So if you want to write it like this, x in the middle, and then put your 2 numbers, and then fill in your symbols. Always use less than because we're doing between the 2. So this is going to have to be less than because it's the open circle. This one's going to be less than or equal to because it's the closed circle. So again, x is between -5 and 3, but -5 is not included because it's that open circle. Okay, we are going to finish this tomorrow.